If we're given a quadratic function, so like this, 2x squared minus 4x minus 3, and we want to write it in what's called vertex form, okay? So that's a times x minus h squared plus k. There's two ways to do it. One is kind of the long way, and one is kind of the shortcut way. So first let me show you the long way, and then I will teach you the shortcut. The long way is called completing the square. And what I want to do is, because I'm allowed to have this plus k on the outside, I'll leave the negative 3 alone. And basically, I want to turn this part here into my a times x minus h squared. So let me rewrite this. So I'm going to write this as f of x equals, I'm going to use a different color. Let me use 2x squared minus 4x, and then let me just do like this minus 3, just to kind of show that I'm focusing on the 2x squared minus 4x. Okay, notice here, I want the a to be on the outside of the parentheses, and inside the parentheses, right, yeah, there's an x minus h squared, but there's no coefficient on that. So in order to make this match this, what I have to do is I have to pull out the 2. Okay, so pulling out the 2, but I'm not going to pull it out from everything. I'm just going to pull it out because that minus 3, basically once it's out, it's out. Like we're not even really paying attention to it anymore. So I'm going to pull out the 2, so it's going to look like this, equals 2, and then I'm going to pull it out just from here. So I'm going to get x squared minus 2x. And then again, this minus 3 is still there, right? Because notice, right, if I had distributed this 2, that's there 2x squared minus 4x. So when I pull out the 2, that's what I want to do, so that I just need a coefficient of 1 right here. So now my goal is, maybe I'll even, let me erase this too, and let me make that a new color, just to show that we're kind of, maybe I'll even put it in blue, just to show that we're not dealing with it anymore. So I'm kind of only dealing with the red. I want to turn this red part, the x squared minus 2x, into x minus h squared. So meaning I want to turn this into a perfect square. And there's a trick for how to turn it into a perfect square. And here's what that trick is. I pay attention to what's being multiplied by x. In this case, negative 2, and that minus is part of it. Okay, so if it's a plus, it's a plus. If it's a minus, it's a minus. Here's the trick. I take that negative 2. Okay, so the negative 2 comes from the problem. Everything that I'm writing in black is standard. I take that negative 2, I divide it in half, and square it. Okay, so the black, even if the negative 2 is something else, right, the green would change based on your problem. The black doesn't change no matter what the problem is. Okay, so you take the negative 2, divide it by 2, and square it. So I'm going to get negative 1. Here, let me do this. Negative 1 squared, which is positive 1. Okay, and this is the magic number that I can add in to make a perfect square. So what do I do? 2 x squared minus 2x, and then here, this is what I'm adding in. This is my new plus 1. And we'll talk about why that's a perfect square in a second. And I still have this minus 3. But I just did something that I really can't do, right? You can't just go adding things willy-nilly, right? I just totally changed my function, right? I had this function, and suddenly I just added more to it, right? You can't just add to it, right? And it's actually not just that I added 1, because look, this 2 gets distributed. So really what happens is I actually added 2, right? Because this is actually 2x squared minus 4x plus 2. So I had my function over here, and this is not the same function. This is the function that I used to have plus 2. So how do I fix it? Well, I fix it by subtracting 2. And that kind of, now all is right in the world. This function is the same as this function, because if I'm going to add 2, right, notice it looks like I'm adding 1, but really I'm adding 2 because it's inside that parentheses. If I'm going to add 2, I better also subtract 2 so that I still have the same thing as this, because otherwise I'm just adding things and I'm just totally changing my function. You don't want that. But if you add 2 and also subtract 2, then they cancel out and you have the same thing. So that's okay. So let me just simplify a little bit, and then we'll talk about this perfect square. And then minus 3 minus 2 is going to give me minus 5. Okay, so I told you this little calculation over here that this 1 was kind of our magic number that I could add right here, and that would make this a perfect square. How do I know what the perfect square is? I look, before I squared, I was supposed to have this guy. Okay, right here, what's inside this parentheses, this -1, before I square it, it actually is always going to come out to be, so I'll just show you in this case, 2, and this is going to be x minus 1 squared, and then the same, this minus 5. Okay, and you can check it, right? What happens when you, I mean, you can also just kind of factor this, right? You can say like, okay, I need to factor this, and this comes out to be x minus 1 times x minus 1, right? But as a shortcut, right, we know it's a perfect square, and it happens to be that it's going to be x minus 1 where you have this minus 1, right? You don't have to remember this. You can just go ahead and factor this, but you can see that this is x minus 1 squared. And look, this is exactly the form that you want to be in, right? A times x minus h plus k, okay? So the vertex is always hk. So I'll say hk is the vertex. So it's x minus h. So this is x minus 1. So the vertex is positive 1, but then it's plus k, so whatever is being added. Okay, so pay attention to those negative signs and -5. Okay, so here there's a minus in the formula already. Okay, so you take whatever the sign is here, and it's actually the opposite sign for h, because it's like this negative is like part of the formula, but here it's plus k. So if this is a negative, this is a negative. And I'll let you guys do the graph, but just to point out, so this is going to be the vertex. I'll kind of start the graph for you. Let me just give myself a little bit more space. If you have a vertex, right, so what does it mean that's the vertex? So we're going to go over 1 and down 5. 1, 2, 3, 4, 5. I don't have graph paper here. And then basically what we're going to do is you're just going to start plotting points kind of on either side of it, and you're going to see it's going to kind of look like this. So here's our, I'm not going to graph the whole thing, but here if we have x, y, if you're going to want to plot points on either side of it, start with the vertex, 1, -5, but then you want to go on either side of this. So on this side of 1, we can do 2, 3, what do they want? They want 4 points on either side. So 4, 5, right? So these are on this side, and then we can also do 0, and -1, -2, -3. And then find the y values for each of those. And what you should find is there's going to be a certain amount of symmetry. So when x is 1, that kind of is, when x is 2, that should have the same y value as when x is 0. And when x is 3, it should have the same y value as x is -1. So it's going to be kind of like here and here. And when x is 4, you should get the same y value as when x is -2. And I can't really do this because my recording thing is there, but there you go. When x is 5, it should have the same y value as when x is -3. So I'll let you do that part on your own.